and welcome. In this Max tutorial, we will display the average color of each frame as a vertical slice scrolling across the screen. There are many websites out there that show you the average color of each frame of a movie displayed like as a vertical slice. So this creates pretty interesting looking pictures. I came across this concept a while ago, so I'm not sure which of these websites is like the original one. I will put some interesting links into the description. Yeah, so this tutorial consists of 3 parts. In the first one, we will get the average color for each incoming frame. In the second one, we will turn each frame or each average frame color, so to say, into a vertical slice that is then scrolling across the screen. And in the third part, we will create a window within the input video to display the slices. Okay, I'm starting with a jit.world object as our rendering context. Here I have a jit.p window to monitor what we're doing. And here I just have an input video. I will just check. So yeah, outputting a texture, volume at 0. Great. So let's start with getting the average color of each frame. So I will create a jit.gl texture. Just to make this a bit more explicit, then say a depth 0. In order to get the average color, we have to convert this into a matrix and then do some matrix operations on it. You can do this with writing your own code in JavaScript. I will use the jit.3m object, which gives us the minimum value for each plane of a matrix, the mean value, and the maximum value. So to convert this texture into a matrix, and that's why we need to convert it, because this object only works with matrices. So to convert this, first I will downsample the texture. So I mean, we could use like this full HD dimensions, but I guess this will be a bit heavy on the CPU. So let's downsample this, doing something like so 16:9 is maybe not enough. Let's do something like 80:45, which is still like the same aspect ratio. So downsampling this, then also a depth 0, so it doesn't change. Let's first take a look at this. So here we're getting like the full HD thing. Then here is the downsampled texture. Then we can use this object jit.gl async read. So this essentially turns our input texture into a matrix. Then we can create a matrix. This has 4 planes, float 32, 80, 45, and then let's again say depth 0. So now we turn this into a matrix. And we can now use this object on our matrix. And now we're getting for each channel. So this, the first one is the alpha channel. Then for RGB, we're getting in this case the minimum values for the whole thing. So this is looking at each pixel and it's giving us the minimum pixel, the maximum. And here we're getting the mean. So this would be then the average color of each frame. So now this is just a list of numbers. Again, I want to convert these numbers into a matrix. So to do this, we can first of all create a new matrix. This time we only need the dimensions to be 1 by 1 because it's just one color. So essentially one single pixel. To fill this matrix, we can, did I just copy it? No. To fill this matrix, we can use the pack object with the command set cell. So this first of all needs the cell we want to fill. So because this is just 1 by 1, we want to fill cell 0, 0. Then we have to tell it which value we want to assign. So I'll set this to 0, 0, 0. And then I can take the list that's coming out here. Oh, this is RGB alpha, so I guess this needs to come here. Let's check this quickly. So we're setting cell 0, 0, alpha is 1, and then here we have the average color. In order to fill this matrix, we need to first clear what's in here. Then we're assigning the list, and then we're banging the matrix, so we're triggering the output. And if I didn't make a mistake, yeah, here you can see now that we have assigned the average color that we're getting out here to this matrix. And now, again, I want to transform this back into a texture format. I know it seems a bit counterintuitive and a bit hacky to come in with a texture, then creating a matrix, and then putting it back into a texture. But as I said, this object is very handy, and it's also harder to get like the average frame color when using like texture operations, like something like jit.gl.pix. Okay, turning this back into a texture. Oh, sorry, didn't mean to do that. This one. So this again can be full HD. And now we have this thing in texture format. Okay, so this was essentially the first part. Coming to the second part, now I want to turn each of these average frames or each of these average frame colors into a vertical slice that is scrolling across the screen. So the easiest way to do this is using a feedback system. So I will first set this up. So we need a jit.gl.pix code box. Then, yeah, I will set this up as usual. So we have input 1 is called color. Then we have feedback. This is input 2. And we can set the output for now just to color. Then we're taking this texture, plugging it in here. Then we need the feedback texture, which is the second input. And then the output is fed back into this feedback texture. And we can also, patch this in here so we can see what is happening. Okay, what I want to do now is I want to like take a thin slice, so from the right side of the texture, and then for each frame displace it by its own size. So I'm taking like a thin slice that's, I don't know, that has the width of the mouse cursor here. And then for each frame, I want to displace it by its own size, like dragging it across the screen and then doing this for all the other slices. So I'm not sure if that was clear, but it should be getting clearer once we're implementing it. So the first thing we need is a parameter. Let's call this one slice size or something like that. Let's set this to 1 for now. It doesn't really matter. Then we need the size of 1 pixel. So this is 1 divided by the dimension of the whole texture. And then we can set, so this is like the input we want to set, and now we can set the adapted size, like taking into account the size of 1 pixel. So size equals pixel multiplied by this slice size. Then, oh yeah, first we need a mask. I will show you in a second why. So mask equals I will just set it to this, and then we can take a look at our mask now. So when we're using the normalized coordinates, here we have just the x component. So on the x-axis, it's ranging from 0 to 1. And now I want because I'm using it later to control where we want the feedback and where we want the input. So if I want to have the input only within the width of our slice and the feedback for all the rest, I'd have to say that the mask, so this normalized coordinates are smaller than our size. And then, of course, only taking the x component. So nothing is really visibly happening because our, slice size is very small. But if I'm making it bigger, you can see that we have this black and white mask. But this is actually the opposite of what I wanted because it's on the wrong side. So what we can do is something like, I don't know, just 1 minus this. Yeah. No. That doesn't work. I can, oh no, I can say this is smaller than 1 minus the size. I think this should work. Yeah, now it's working. So again, in this part of the mask, so when it's black, I want to get the fresh input. And here I want to have the feedback, and the feedback is dragging everything along. So to create this dragging across the screen effect, I mean, I guess I can just delete this, put it in here and say we're sampling our input 2, which is the feedback input, at our normalized coordinates. And then we need an offset. And so this offset will be applied repeatedly. So imagine we're moving this slice 1 unit to the left in the current frame, and then in the next frame it already will be 1 unit to the left, so it will move 2 units, then the next frame 3 units, and so on. So we're moving it only on the x direction, so the offset on x is 1 and on y it can stay 0. And then we're also multiplying this by the size to tell it how much to move. Make this a bit bigger. Yeah, maybe we can do something like this. Okay. So what is happening if I'm just using the feedback? Yeah, it's just taking the mask because that was the last input and it's dragging it across the screen. We don't want that. What we want is we want to use the mix operator, so we can say, okay, if this mask is 0, we want to use just the color input, and if this mask is 1, we want to use the feedback input. And now it's going pretty fast. If I put this to 1, you can see that each slice of the incoming picture is only 1 pixel wide. Now it is 5 pixels wide, and it goes faster. So again, looking at the mask, when it's black, we're taking the new input, and when it's white, we're taking the feedback, and then the new input is fed into the feedback, and this drags the whole thing across. Yeah, let's keep it at 5. I think this concludes the second part. We now have the average frame color as a vertical slice. And in the third part, I want to integrate this into like the original footage. And to do this, first of all, I will make some space. So what we need now is this original texture, so we can combine it with the average frame color slices. Maybe put it like this. So I will again use a jit.gl.pix code box. And essentially what I want to do is I want to create a mask where, okay, every time the mask is black, I want to display the original picture that's coming in, and every time it's white, I want to display what's coming in here. So I think we should just start with creating this mask. So I'm taking this output, putting it in here. So how can I do this? Okay, I think first of all we need a position, so where we want to position this mask. I don't know, let's set it to something like 0.5, 0.5 for now. So this will be the X position of the mask, and this the Y position. Or let's call it window. So we will create a window that displays the slices that are coming out here, and this is the position of the window. And then we can also create the size of the window. So let's say the size is, I don't know, 0.25. Okay, let's first create the mask. What's the best way to do this? I think to make it easier to understand, I will just start with the Y component of the mask and then the X component of the mask, then create the Y component of the mask and then combine them. So again, let's assign this to the output so we can see what is happening. Again, here I'm using the normalized coordinates. So now it's just, okay, nothing is happening because I have to play this input video. Okay, so now you can see this is just our normalized coordinates. So we only want them when they are bigger than our position, because this is essentially what the position means. So pos.x. So you can see our position is at 0.5. So when we're bigger than 0.5, this means that the window is starting. So this determines the position. And if I assign this from the outside, you can see that I can change the window position. But so now I have the border on the left side, but I also want the border on the right side. So I can use this AND operator. So I want the window, or I want this to be white when it's bigger than this, but also when our normalized coordinates are smaller than the position we have plus the size. Yeah. I hope that makes sense, because so this left border is just the position, so where it starts, and the right border is the position plus the size of the whole thing. So if I change then the size from the outside here again, you can see that we can change the size of our window. So now we can do the same thing for the Y component of our window. The only thing we have to change here is every time we're using the X component, we're changing it to the Y component. And now we have the same thing for the Y component. And of course, this has to be between 0 and 1. And now we create the whole mask and say this mask equals the X component times the Y component. And we can also display this thing here. Yeah. Now we can change the size of our window and the position of our window. Yeah. Okay. And now, so the whole idea is that we can now say, okay, we use this to create the image. So if this thing is 0, we want to have input 1. And if this thing is 1, we want to have input 2. Oh, yeah. We also have to plug this in here. But the problem now is, as you can see, okay, I will set the position to 0, 0. You can see that we're not getting like the whole image that is coming in, but we're only getting a small part of the image. So what I want to do now is scale. So maybe this makes it a bit clearer. So this is the whole thing. And now we're only getting like a small fraction of it. So what I want to do is scale this whole thing to be exactly the size we need. To do this, first of all, yeah, let's create UV coordinates. I will also display them so we can see what is happening. Okay, UV coordinates are normalized coordinates. Now you can see they're ranging from 0 to 1 on the x-axis over this whole screen and from 0 to 1 on the y-axis over this whole screen. So in order to scale them, we need to first of all make them smaller. So this, exactly this window, or this range from 0 to 1 in both axes has to become smaller. So we can just divide it by the size of our window. And now you can see that, like, essentially what is happening is that this range from 0 to 1 is in the top right corner, but it's going like from here to about here, and from here to about here, and everything else is just above 1. So if I change the size, you can see that these coordinates are also changing. So now theoretically we have the right UV coordinates, but they are at the wrong position. So to put them to right position, we can, is it add or subtract? I'm not sure. Oh no, I think it's subtract our position. But oh no, that's still not quite right because we also have to divide the position by the size. Okay, so what's happening here? I mean, to make it clearer, we can also multiply this whole thing by the mask. And then you can see that we have our normalized coordinates from 0 to 1 that are always going from 0 to 1 and adapting to the position and the size. It's not that clear to see when we're doing something like this, because now the window is in here and everything else can be just ignored. So then of course we can use these UV coordinates to then sample what's coming in here. So we can create a new variable, call it, I don't know, average color in or something like that. And this is, so using a sample operator into using the UV coordinates we just created. And then this should be working. No, I also have to put it in here. So now it's working. Now you can see that if I plug this in here, that we're getting the whole thing. Yeah, doing something like that. Yeah, now we have the input video and we have the average colors scrolling across the screen. Yeah, when changing the slice size, bigger slices of course mean that it's going faster. Smaller sizes means that it's going slower, and yeah, I think it shouldn't go below 1 because it wouldn't make sense. So 1 is the size of 1 pixel, 2 is the size of 2 pixels, 100 is the size of 100 pixels, but it's going very fast now. Okay, let's keep this at 5. Yeah, I think this is essentially what I wanted to show you. Yeah, I mean, you could also just display these average frame color slices on the whole screen, or you can do it with this window, or you can also use this window thing to display something else. Because it doesn't really matter what's coming in here, we could also do something like this. Or something like this, just the current average color, but I really like this scrolling thing. Okay. Yeah, so this is essentially what I wanted to show you. I hope you found this useful, and thanks for watching.